Thank you, thanks. Imagine the first people to ever sit on a train. And I mean like the first kinds of trains that were ever made. Those people must have been like, oh my god, because I mean they had like been walking and maybe horseback riding for their whole lives. And they must have thought, this technology is amazing. If we just build rails everywhere, we can go everywhere. Now the sky is the limit, you know. And maybe there was a little physicist on that train. I'm allowed to make fun of physicists because I am one. And maybe he said that, okay, so the more coal I put into the engine, the faster the train goes. And then he made a little line between his points, and then perhaps he extrapolated wildly and said that if I build an infinitely large engine and put an infinite amount of coal into the engine, can this train go infinitely fast? And now we can sort of chuckle a bit and say that, yeah, no, it can't, because you have some architectural limitations going on. There's quite a lot of frictions in your rails, and then there is air resistance in front of your train. And then also there are physical limitations that you just don't know about. You have just the sound barrier that you're going to bump into, and then later there's the speed of light also. So no, trains are good, but you can't go infinitely fast with them. And now looking at this little plot, does that remind you of anything in AI discussions? Like if I change the axis labels a bit, there is this funny thing going on where we think that we just keep throwing processing power at our problems and at our machines, then intelligence will pop out. And inspired by the little train example, can we think something like, maybe not. There is actually, we don't have like any indications of general intelligence popping out of anything yet. And if we think about the one general intelligence we know of, that's us, right? That's our brains. And our brains look nothing like the von Neumann machines. Not the same architecture at all. And then there's Moravec's paradox, which was actually formulated already in the 80s, which says that high-level reasoning requires pretty little processing power. So there is definitely something more going on there. And also, for all we know, there may be physical limitations to this. I don't believe that personally. I don't think carbon is so special. But you know, for all we know, there may be limitations in our processors and transistors that we still have to bump into. So I think it's important. I'm not insinuating that any of you are scared of AGI, but much of the public discussions are centered around it because it's easy to make headlines with it. Now, I think that what we need to do is to take those discussions down to the systems that we are currently making, machine learning and stuff that we call AI, and then we have to think about what can go wrong and what do we have to worry about and what can go really well with these systems that we're building right now. So thinking about your job in AI and machine learning, what you can actually do with that is contribute to build a better world. Because data analysis is definitely affecting the world, right? There is no arguing about that. And today I want to share some of my kind of most recent thoughts on this, on what we have to take really seriously and what we have to discuss and solve right now. Those are two topics, and the first topic is data. Because as you all know, there is no machine learning without data, and also, unfortunately, you have this effect of crap in, crap out, right? So let's be inspired by machine learning and look at the past. Is there something to learn there? And yes, I think actually if we go all the way back to the 1400s in Venice, there's this guy called Luca, and he's known as the accountant who changed the world. Now you don't hear that often, huh? Accountants changing the world. But what he did was he invented this thing called double-entry bookkeeping. It's a marvelous system, because when a merchant starts the day, when he opens his store, what he's supposed to do is write down how much gold he has and how much he has of pepper and potato, or whatever he sells. And every time he makes a transaction, so every time he sells something, he's supposed to write down a new number of gold coins and goods that he has. And now you're like, yes, obviously you should do that when you're running a business. But this, just like washing your hands after touching something filthy before eating, this had to be invented. And this was so powerful that it changed the world. It created modern finance based on this. And the reason it could change the world is twofold. One thing is that it just works really, really well. It's easy to adopt, and it just works, right? Before this, people basically kept diaries. So in the morning, they would open the store, and they would just, do their things, and in the evening, they would write in their diary, kind of like, nice day, sun shining, now I have this and this many gold coins. But meaning they had no chance of doing like data analysis on which goods sold well, and maybe if some money was disappearing for different reasons than sales. And also, this happened at a very opportune moment, at the right time, at the right place. Because Venice was pretty much a center, a global center for trade and finance, meaning that anybody who traded with these guys who used the system were inspired and kind of incentivized to also use it. And you might have heard of the Medici Bank. Medici is Italian, it's plural for medico. Medico means doctor, and this poor guy up there was the first we know of the medico, so he was a doctor from pretty low class, lived outside of Venice, and he decided, I'm going to go into banking instead. And he was one of the first guys who started to using this standardized format. And before he died, he was like the most powerful rich person on the planet. I mean, he founded the Medici Bank, the Medici Empire, who was so silly rich that they basically paid for the whole Renaissance because they wanted art. Thanks to a standardized system which was easy to use and which nobody had thought about. And to take a more recent example, containers, not the containers we like, but the ones you have on ships, that pretty much revolutionized the shipping industry. Because before containers offloading a ship could take like a week. Now it takes about an hour, right? You grab the container, put it on the train, and off it goes. Now imagine the future where you can say, oh, it used to take me like weeks to get all the data for my project. Now it takes me an hour. I mean, that's kind of brain explodes, kind of amazing to think about. It's pretty utopian, but it is definitely the future that we are and have to be working towards if we want to build a data-driven society. And actually on the train going to the airport on my way here, I was scrolling around on LinkedIn and I stumbled across this Netflix blog where the Netflix data scientists, they're pretty cool guys, huh? Where they say that some of the hardest things about working as a data scientist in Netflix are difficulties related to data access, data processing, and probably also data governance issues. And this made me think about this in kind of a third way, because so when I talk to data scientists, they say that, well, data scientists are expensive, right? And they say I spend a lot of time on mundane data tasks, which I hate, which take my energy away, and companies have to pay for that. Also, very often what companies do is that they structure the data piecewise, like now I want insight from this data, so I make a data warehouse and structure this, and then maybe they don't do that for the rest of the data they're lying around. There's a lot of lost value in all the data that then won't be analyzed. And then now I learned from Netflix that there's a third aspect to this. When you have your data in order, you're definitely going to attract the best data scientists out there. Now, if that's not a motivation, I don't know what is. But an uplifting thought here, even though I know that probably most of you and I also hate the little data struggles, the labeling the data and getting the data in the right order and then getting a lot of errors because my matrix wasn't in the right format. But if you turn around this thing and just think about what we're actually doing, is we're preparing the world for a more intelligent future. And in this effort, global data science communities, open source codes, and meetings like this are immensely important. Because it is important that we don't go around inventing the wheel and reinventing solutions like on our own, on our little job. it's important that we pull in the same direction and learn from each other's mistakes and progresses. And we're definitely heading in the right direction on this, so I'm pretty confident that we'll land on common data standards, and just like the Medicis, you know, great things will come out of this. But in the meantime, or once we've solved the data issues, I'd say there are still other things that can ruin this for us. And you can summarize that, I think, in misuse and misuse of the tools that we build. I mean, I almost think that it's even worse to think about the tools we could have built and don't build for various reasons. The places where human beings do tasks that AI or machines could have done a lot more efficiently and a lot better, and the humans could have gone and done stuff they would rather like to do. But there's also the misuse aspect, which is using AI in a bad way, being unethical, and also using AI in the wrong way as just thinking that it does one thing, but then it's actually doing another thing that looks pretty similar. And to start off this, I would like to share a bit of a cute example with you, which is from Norway, in the city where I live. So I have to tell you about a pizza chain, which is like Scandinavian's most popular restaurant chain. It's called Pepper's Pizza. And what they tried to do at some point is that they tried to do, no, I'm not going to start there. What they did is that they put up a pretty ugly advertisement sign on the main train station of Oslo. It's the capital of Norway. And it was ugly because, as you can see, it has like a wooden frame with a hole in the top. But nobody really noticed, and it was like showing pizzas and salads and whatever they serve. But then suddenly, something went wrong with the sign, and it started showing things like male 20s, 0.4. And then it said female 30s, 0.6. So what was actually happening, the reason for the ugly hole in the frame was that there was a camera, and that the camera was doing facial detection, estimating the gender and the age group of people, and then measuring how long people would look at which products. So basically stuff like, will a man look more at pizza? Will a woman look more at salads? And this is kind of nothing new. It's just that before facial recognition, what this pizza chain would have done is hire a consultant, made him hide in the bushes, and then he would have had to go like, male pizza, yes, so and so long. And you can even argue that, because the only thing that was stored here was actually estimated gender and age group. This advertisement sign recorded less information about people than the consultant would have done, right? Because he would have remembered the people. But still, Norwegians hated this. They were so angry. I mean, this was in the newspaper, it was all over the place. And I'm certain that if this hadn't been Pepper's Pizza, which we really love, if it would have been a small chain or a foreign chain, this would have been a reputational disaster and would have driven them out of business, basically, especially in Norway. Because people are still skeptical, you know, towards robots making decisions and automated decision-making and surveillance. Because this was kind of surveillance, right? I mean, you can't blame people. Because when we hear about AI and surveillance, we hear about dystopic things that used to go on in Orwellian literature, which is now actually going on the other side of the planet. And I think that most high-level conversations I have about AI these days mention China and what they're doing in some form or other. And it's pretty clear to me that we're like, oh, what they're doing is unethical, right? But when you think about it, what do we mean by ethical? By ethical, we mean our ethics. I'm going to be a bit coarse here, just divide into Eastern and Western ethics. If you think about the Eastern ethics, the Chinese ethical model, there's no Aristotle, Plato, Socrates in there. I mean, the good life, right, that's the game of ethics. The good life is determined by how you live in relation to other people. That's not our ethical model. Our ethical model is, I'm free to do what I decide with my life and my data, and if you want it, you have to ask and you have to pay for it. Right? That's my data sharing model. That's what GDPR is based upon. Now, there are two facts here that we just really have to be be aware about. One thing is that this Eastern data sharing model, whether you like it or not, is just perfect grounds for building machine learning models. Obviously, lots of data, better models, that's where we are today. And the other thing is that me owning my data, it is easier for Google and Facebook to ask for my data than it is, for instance, for the Norwegian healthcare system. Because Google and Facebook is just better at asking the right questions. So I'm actually sharing more of my data with people who want to earn money from me, or corporations who want to earn money from me, than the corporations who want to help me if I ever get cancer. This is a problem we need to solve. I mean, nationally, or preferably in all of Europe. And I think we really need to take the discussion down from oh, we're scared of what's going on in China, down to, but what are we trying to achieve right here? This is the discussion we need to have, and we need to lift the discussion up to people who are not technical, who don't know too much about AI, and just go hey, your data can be used for good. This brings us into more of an ethics discussion, because ethics is not just about what you do with data, but what you do with the algorithms afterwards also. And it seems to me 2019 has been a bit of the year for AI ethics, and that is good, we're already talking about it. Not only that, we're also making ethics committees and ethical guidelines, which is good, but I think there are weaknesses in these ethics committees and ethics boards that are being put up. One of them is that they tend to break up. The other thing is that sometimes guidelines come out of them, or usually guidelines come out of them that are pretty high-flying and wishy-washy, and it's impossible to know what you're actually supposed to implement from them. And also, very often they don't address the questions that, for me, implementing this AI, are important to get answered. And I want to illustrate that by one example, which is our favorite bad guy these days, bias, making headlines like never before. And in this Amazon case, this happened right because they trained on some population, and they inadvertently made the assumption that this population is representative for the population I want in the future. Now, it wasn't. But the thing is that bias is really just a different word for a predictor you wish hadn't been used. So when I talk to non-technical people and they go yeah, can you make an unbiased algorithm? Or are you sure that it's unbiased? I'm no, bias is information. It's if you take out all the bias, you take out all the predictive power, right? What you mean is, will it discriminate against groups you don't want discriminated against? So we have to be a bit more precise. I mean, it's okay that the headlines go algorithm was biased, but when we, with the background and statistics, try to fix this, we have to be a bit more precise. And it's not as easy as over and underrepresented groups. I mean, here, this Amazon training set probably contained I don't know, 90% men and 10% women, so that's kind of easy to spot that there's going to be something biased going on there. But you can have perfectly balanced training data, and the same thing can still happen. We have a fairly recent example here from the US healthcare system. So they saw that we have a lot of elderly people waiting in line to be treated. Now let's sort this line in a good way so that the most urgent cases, get medical attention faster. What ended up happening was that a lot more white people got treatment before black people. How could that be when the training data was balanced? Well, it was basically because of the measuring of the loss function. Because what they were asking the algorithm to predict was how much will this patient cost the healthcare system? And for historical and cultural reasons, white patients have been more expensive for the healthcare system for, obvious reasons. So this could be easily circumvented by just changing the prediction to instead, how often will a medical condition reoccur? And then suddenly the discrimination was gone. So I think this is a very important point to think about. It's not as simple as, is your data biased or not? I mean, your data contains the maximum amount of information, and then it's up to you what you do with the model that comes out of the data, and what you ask your model to predict. To illustrate this, the father of artificial intelligence, Marvin Minsky, once went into the office of one of his students and asked, like, what are you doing? And the student said, well, I'm training some nets, and I'm randomly initializing the weights so that the bias will be gone. And Minsky looked at him, and then he closed his eyes. And the student was like, why do you close your eyes? And Minsky said, so the room will be empty. Things you can't make bias go away. The only thing you can do is be aware of it and mitigate it. And actually, AI in automated decisions is good news right now, because the bias and discrimination has already been here. What AI does is systemizing it so that you can see when it happens systematically. Instead of a bunch of judges being racist and biased on their own and maybe not even noticing that they are, we get these uncomfortable headlines, and we see that there is some systematic unfairness going on, and then we can fix it. We can have a public discussion about it, and we can fix it. Because fortunately, it's easier to change algorithms than it is to change people. However, bias is not even the most difficult part of the discussion, because we have this thing called fairness. And fairness is a societal construct. That is one thing. What one society deems as fair is different from what another society deems as fair. And also, different fairness definitions are very often mutually exclusive. So I'd like to illustrate this using another example from the US. Aren't they just marvelous? Which is Compass. I don't know if you've heard about this. It's this algorithm that is supposed to help judges decide whether a defendant should go to jail while defending trial or not. So what it basically does, it calculates a risk score. It's like some kind of probability of the defendant doing something stupid while awaiting their trial. Now, of course, this algorithm is not trained on ethnicity. Could it still have racial bias? What do you think? Who here thinks that it could have racial bias? I want to see all of your hands go up. Yeah. It might as well, you know, be an ethnicity predictor, because there are social differences, cultural differences between white and black people in the United States, and that's just the way it is. So what the algorithm does, as I said, is it calculates a risk score, and that risk score you use on each single individual defendant to decide whether they should go to jail or not. Now, unfortunately, people aren't all that easy to predict, so the picture is not going to be like this. It's not going to be like you can find a perfect risk score above which everybody should be jailed and everybody else should be let out and won't do anything stupid, right? Reality with human beings is a bit more like this. You're going to put some people into prison that you shouldn't have put into prison, and you're going to let out some people who will end up committing crimes which you should have put into prison. That's also just the way it is. But the uncomfortable headlines show up when this effect of that white and black people are just two different groups in our data, whether we like it or not. And it turns out that these white and black people are jailed with different frequencies. Now then the question is, what would be the fair thing to do? Would the fair thing be to wrongfully imprison black and white people at the same frequencies? Or is the fair thing to do to treat one individual with the same risk score, or with one risk score in the same way, independent of their skin color? I mean, both of these sound fair, right? The thing is, if we use the same risk score for black and white people, what happens is that a lot more black than white people are needlessly jailed. And that's what's generating the headlines, right? I mean, we're imprisoning a lot of black people and not white people. Why is this? This is obviously racist. This is unfair. And the problem is, if you want to change this without changing like society, what you can do is you can have different risk scores for the different ethnicities, meaning that black people will be jailed at a higher risk score than white people. But the problem then is that you're literally discriminating, right? Because you treat two people differently based only on their ethnicity. And that is actually forbidden by law. So what we see here is that we have two fairness definitions that are just mutually exclusive. You're going to be fair either to individuals here or to groups, but you can't do both at the same time. It's a bit of a statistical fact that's going on here. Now, you as a developer, or a statistician, or a data scientist, you're going to notice this when you try to implement your systems and have your fairness accuracy trade-offs. The thing is, you should not be put into the position where you have to make these decisions. I mean, what is fair in our society? That has to be decided via a democratic process, right? I mean, this is a political decision, it's not a technical decision. But the problem is that it's we technical people who discover these problems. Meaning that when we do, it's very important that we lift these discussions up. I mean, these are the discussions I wish were making headlines instead, but at least they have to go, like, you know, to your boss. Jumping over to my first and actually my favorite discussion in AI is the whole not understanding what's going on. As I said, I'm a physicist. I think it's very important to understand what's going on underneath. Having an algorithm which makes good predictions is like, yeah, that's very nice, but if I don't know why it's making good decisions, I don't know for how long it will continue doing that on samples from a new distribution. And also there's this whole causality discussion. So to illustrate, it is actually a fact that babies that are born too early have a higher chance for survival if the mother smoked during pregnancy. And now when you hear that, you go like, no, because smoking is unhealthy, you shouldn't smoke during pregnancy. The trick is that smoking during pregnancy can be a reason for babies to be born too early. So that means that if you as a baby are born too early, it's good for you if it is because your mother smoked. But of course it would have been better if she didn't smoke and you weren't born too early. The thing is that no matter how much data and processing power you throw at this problem, today's machine learning systems will not figure out this causation for you, right? Because what is machine learning? Machine learning is here, you have a bunch of data, make a model and give me a prediction. Now I think that the word prediction is a bit of an exaggeration here, because if you can, like, you know, if you can predict the future, it sounds like you've understood the causal connections of the cosmos somehow, right? You understand what causes what. That's not what machine learning does. Machine learning, or a machine learning model, what it does, it takes a data sample and goes like, what does this remind me of? And then it basically puts it on some side of a decision surface or into a ball or into a cluster of whatever it looks mostly like. So I'm not saying that we should all change the words we use, but perhaps think about machine learning and prediction more as association. Now, that is not to say that machine learning is not powerful. I mean, just think about some of the feats that machine learning has achieved. My favorite achievement from any machine learning model is when Deep Blue, or equally now Deep Zero, keep beating human beings at chess. And it's not sort of to like rub it in, but okay, so the first time when Garry Kasparov was beaten by Deep Blue, that was the first time he was beaten at all. He had never lost a game before that. And he said it was so devastating, it hurt physically. And he said it took a long time to get over that. But when he got over it, he said, the way he got over it was by thinking that, you know, numerical, statistical optimization of problems is always going to beat human beings in a closed system. Think about that. Just if you zoom out far enough, the world is actually a closed system, right? Because we get some energy from the sun and we blow out some CO2. But our problems all exist inside a closed system, and very many of them can be solved by using prediction well. But using them well is really the key word, because we, who are literally these days, creating our AI future, we have to remember what machine learning does is correlation detection. Machine learning doesn't understand the context in which it operates. It doesn't understand what is wrong or right. It's really just a tool, like a chainsaw. We still have to do the thinking for it, and I think we have to be very, very ambitious regarding understanding what's going on. I didn't get to talk about explainable AI today, but I really hope that that is going to be a field with a lot of focus. And even though now it's difficult to look at deep neural networks and say that, well, okay, so here I have a 10,000 dimensional feature space. If I was able to actually describe this analytically, that would mean I had solved the curse of dimensionality and I wouldn't use machine learning in the first place. That's okay. But still, let's try to be ambitious and let's try to understand what's actually going on, because that's where intelligence lies, and as far as I know, we're the only intelligent ones here, right? That's all I had today. Thank you very much for listening.
Thank you, Inga, for your talk. Questions? Yeah.
Thanks, Inga. It was a nice presentation. I just have one question about your ethics. Let's say if tomorrow Palestine got AI stuff and the Hamas, do you think they will even blink for a second to strike Jerusalem within a second? As per you were saying that we should have to be all intelligent, we should have to be all good. Do you think it will happen in near future?
Could you repeat the first part of the question? I didn't catch it.
Okay, repeating again. Do you think, I mean, you're talking about the ethics and the data. You're also saying that machine learning is nothing, it's just a tool. But for data engineers, machine learning is the religion. As this is our only one particular tool for which we can help the human society. But as you're saying about the ethics, if tomorrow Hamas or the Palestine get any AI tool, do you think they even think for a second to strike Jerusalem? And or in this case that when Cambridge Analytica took the data from Norwegian data centers and helped Donald Trump to be the president of the United States, do you think what happened to ethics at that time?
Yeah, I think you're really hitting the nail on the head with that question.
Yeah, but then you started it.
Yeah, and not like you shouldn't have asked it. I mean, it's an excellent question. Okay, so what I really kind of like about AI and machine learning is how it takes questions or problems that we already have and then really, really exaggerate, or not, but really lifts them like into the daylight. Because the scenario that you're describing would then be made possible by AI, but it's not a scenario that AI like caused. I mean, the cause for our problems are in our past and are human-made, right? So it's just like going from how do you call it, bows and arrows to machine guns, right? It's about that we now have a more powerful tool at our disposal. You can use it as a weapon, or you can use it to make good things. But what would then happen is really independent of what AI is. It depends on the people in power and the people in the position to make those decisions. So, as a data engineer, you can't make that choice, right? What happens to the ethics depends on what the people in power think about the ethical questions. So, the way to affect those decisions is, like always, through the democratic process. I know, what do you think? Like, what does anybody think?
Well, I am not satisfied with your answer because the way you started the presentation and then you concluded it, it's like a wide angle. We call as 2 pi in our mathematics. Thanks.
2. Can you repeat the last?
2 pi, 360 degree.
Yeah. Okay, so if you want to want me to summarize in 5 seconds what I meant by my presentation, it is that we are definitely going into an era here with great challenges made possible by AI, and all of these challenges we have to address like a society through our democratic process, but very many of them are challenges that we have to make society aware of because we are the first ones to spot them, because we understand the technical aspects of this and we understand exactly what we need to program in to avoid one thing to happen or which fairness metric to use, because it just boils down to real statistics. So I'm not saying that we have to solve the ethical problems, I'm saying that we have a great responsibility in making society aware of them and exactly how they have to be addressed, because then we go back and implement them. You still unhappy?
Okay, so maybe you can...
Not whatever I say, I mean, I'm just one of you, right? I mean, we need to have these discussions, but I also think that we need to have them in a kind of a, what should we do to solve this way? Like, does anybody want to comment on that? Yes?
Hold on.
Yeah, I have a tiny problem with democratic process. It's the best way of making decision nowadays. But if you, for example, ask people, I don't know, 100 years ago, if women should vote and if it's good, they would probably say that it's wrong.
Yeah.
So it's kind of problematic to, yeah, like, of course I understand that this is the best way of probably to make that decision, but still I'm not satisfied with it. So it's good to have discussions. Of course, we should raise the awareness and show the issue to other people, but yeah, maybe democracy is obsolete nowadays. I don't know. Hard to say.
Yeah, well, I think definitely AI will help us in our democratic process, because it will, as I said, it will really systemize the way that we see the things that are going on. Like 3 discriminating judges on each their end of the US, it's hard to put that into a system. But when you train an algorithm based on their decisions, you say like, oh, there's a lot of discrimination going on here. So I think it's not AI, it's data analysis really that can help us and make us aware of the problems that we already had also before AI came, but that we need to address. And whether or not democracy is a good thing, I mean, that is a discussion for at least lunch. Right?
I would say a bottle of vodka, but...
A bottle of vodka, yeah. Yeah, 1 bottle of vodka and all the problems of the world. Yeah.
Yeah, I don't think it's so simple. One wouldn't be enough, probably. One more question before coffee break. Yeah, the one in front.
So I would like to come back to the presentation and to the last part of it. So you mentioned that we mistakenly claim that the correlation is the causality, and I think this is the part of the bias. So do you think we can apply the models, we can develop the models that try to find causality, not correlation, in deep learning?
Yeah, well, I mean, it's difficult with real-life data, right? Because in real life, if you have 5 variables, it's very hard to keep 4 of them fixed and only vary the last one and check if there is causation there. But I mean, given the amount of data that we can find in some domains, yeah, definitely classical statistics can be used combined with machine learning to try to find causation and try to really pin it down. But I think it has to be combined also, of course, with human domain expertise. So there, I think the human in the loop approach is fruitful, at least now. He wants to answer.
What I meant was that the statistic and econometrics have methods for finding causality, and so can we take on it to the deep learning and somehow apply these methods from the fundamental statistics into deep learning?
Yeah, I'm glad that you said econometrics, because very many of my explainable AI arguments, fierce arguments that I have these days are with econometricians, because in econometrics you come kind of from a universe where, or from a world where it's actually really difficult to say what affects what, and it all ends up in kind of a global economy where politics affect stuff and then individual decisions, and it almost seems a bit like there are stochastic processes going on. So economists tell me that you can just forget about finding the causal relations inside problem. And then I come from physics, and in physics I know that there's some underlying law controlling everything, so I just need to find the law of nature. I mean, there is probably a PDF of the universe. So I think those are two different schools that need to communicate better. Now, to answer your question, I don't know, but I really, really hope so. Yeah.